So my name is Sean Kelly, and I am leading the material and service sales in EMEA. I'm happy to support Norm today with his experience days for Additive. In my presentation, we'll take a look at requirements for production. We'll take a look at what's still required today. We'll take a look at the metal material story. How did this all begin? And what challenges we face there? We'll take a look at the technical readiness levels. This is filling in the gaps of grey areas that we have in Additive today still. And then we'll take a look at the polymer materials. So a question to the audience. What is the most important thing when it comes to additive manufacturing in production? Anyone? So what is the most important thing in additive manufacturing when it comes to production? Please. Oh, my ears are very tiny.
Can you hear me right now?
I can hear you now.
There is some parameters for laser power, scanning speed, height space. These kind of things are important for us, actually.
What does it give you?
Excuse me?
What does it give you? These parameters, these process?
Let's say great shape products.
Yeah.
Well-suited parts.
Okay.
And so
getting
on.
Close, actually. Getting close. Reliability? Repeatability?
Of course.
Yes.
It depends on the repeatability.
So for additive, what's the most important thing for production is repeatability, repeatable quality. And the only way to do that, we're skipping. And the only way to do that is to fully control every corner of that production. Yeah? You have the system, you have the process, and you have the material. In a few of my colleagues' presentations, you've seen the triangle in different variations. In this presentation, you're going to see it a lot, you're going to hear it a lot, and you're going to hear the word quality and repeatability a lot. This is a 2020 report of the 5 top topics stopping additive manufacturing from going into full-scale production. The first, slow production speeds. The systems were not fast enough. Inconsistent material properties. There is many different suppliers, let's say 316L in the world. Yeah? All of which have different PSDs, different types of 316L that they say is agnostic for additive, but none of them run it on the systems. None of them understand the systems. None of them understand the parameters. So what you get is just a general 316L, and they hope for the best. Part-to-part variation. This comes from the material inconsistency. Yeah? You cannot have repeatable part quality without understanding the system, process, and material. Industry-wide standards. This is what we've also talked about for different industries. Yeah? Aerospace, defense, medical. With EOS, we work with you guys to support and guide through these needed industry standards. And then available uptime. How much uptime can the system really give you per year? Now, the good news is, EOS is working on all 5. Our newest systems are bigger and faster. I'm not pressing it and it keeps going ahead. It must be a timer. We lock in our material properties. We're able to achieve the best part-to-part quality in the whole industry. We have many industry standards already created in our last 35 years. And the uptime of our systems is consistently going up every year. At the moment, we achieve over 90% uptime on our systems. Metal side. Polymer is a different story. Today, EOS has been in the market for 35 years. When you think of EOS and think of additive, most people think polymer systems, metal systems. What they don't think about is the materials. Right now, today, EOS's materials is over 1/3 of its business. So we have a metal business and a polymer business. We have metal materials, polymer materials. And we've created in the last 35 years over 90 materials for polymers and metals. That is the biggest material portfolio for AM in the world, for SLS and DMLS. But what makes us different to other suppliers? When using EOS system, process, and material, you'll achieve a higher quality than anything you can achieve in the market. We are creating product transparency. Today, there's still a lot of gray areas when it comes to using a different parameter, using a different material. What we're trying to do with using our triangle is there is full product transparency. Also, how mature is that material with that system and process? A lot of people say, yes, this material is available on an M290 or an SLM, whatever. But how mature is the process? How much data is backing up that material and process today? And that's where it gets very surprising, what's really behind. When you talk to material suppliers, how mature is that material on AM systems today? How much data do they really have to back it up? And how it will perform with your application? With 90 materials, we're trying to make an easier choice for you to find a solution in our portfolio for your application. Faster time to market. Due to the last 35 years, we've been collecting data. So we have a huge extensive data on our material development and exactly what we'd expect a new material to do. So we can use that data to bring a new material to the market in record time, having a good idea of what will happen next. And predictable results, again, coming from the data. We know what to expect from our materials. We know what to expect from the application. We have a very good idea where we'll end up. So the EOS metal story, not very widely known in the market. In the late 1980s, Electrolux in Europe, R&D, were looking at materials and metal powder to use an additive already in the late 80s, but they didn't have it achieved. Yeah, they had the idea, and they started the testing and the experiments. In the early 90s, Dr. Langer found out what this group was doing and decided to create a partnership. He too also believed in additive going into metal. Yeah, and at that point they started developing the very first process material. Yeah, so AM machines, the way we see them today, these DMLS machines, they came from this moment. What they started off with was a material, a laser, and oven elements actually was the original. We're talking standard oven elements. And from that they built the machine around the process. That's where the machine came from, around this process, around the material. At the time it was called DM20. For any use that was in the market 30 years, DM20 was the first material brought to the market by EOS. It was supposed to be a general purpose material, a general purpose metal. But it didn't go too far. Why? Because the industries were looking for known materials from their industries. They were looking for stainless steels, super nickel alloys, titaniums. Didn't work with the system, didn't work with this process. Not yet. But they wanted to go that direction. In 6 years, EOS Finland was founded. I've just come from there this week. It's based in Turku. And they started to develop the processes and the materials you know today. If we go back to the year 2000 and you ask for a 316L for DMLS, no one was providing it to you. They don't know what you're talking about. If you ask for a titanium, still don't know what you're talking about. They actually don't know what AM is actually at that point still. But these Finnish people here developed the very first PSDs known to the market today. They're standard 316Ls, MS1s, titanium, super nickel alloys. And there they started to develop. There's when we brought our first system that would have argon and nitrogen and being able to process stainless steel, super nickel alloys and titaniums. As early as there. The market responds well. We start to grow. We start to see different applications coming in. Those used back then would have seen a very famous video of us doing a tooling application. That's one of the oldest videos you can find of EOS being successful in metal is the tooling application. But energy was calling. The turbine sector was calling at this point. And then we brought in our super nickel alloys. Alloys that can withstand much more heat. In 2021, as we built a large portfolio, we realized that we couldn't create everything without having the industry's input coming in as well on a large scale. So we created a custom material and process team. This is a team that will take any application that's coming in and evaluate with their data if it's possible for them to build a material, a mature process to develop for that application in additive. At the moment, EOSI has 43 employees. They're generally still creating materials today, but only per application. For us, it's important that the customer is successful, yeah? And having one point of contact being us. This is an advantage as well. A lot of people like to decouple. In additive, it's very risky to decouple because you become responsible for the material. You become responsible for the process. You become responsible for the end part. Now with us, you're still responsible. Yeah, I'm not going to take that away from you. But if there's an issue, we are able to investigate. We have the data to investigate. It's one place to go. We can't blame someone else in this process. It's just us. This saves time. It saves money. So again, this is to give you a picture. My little map I built. This is the EOS'un in Turku. Again, over 40 people. We got a 250 square laboratory, over 600 meters of production. We have 12 systems at the moment there of M290s and M4 class. And basically for qualifying the materials and also R&D work on the processes. Again, the famous triangle. Without having each corner of this triangle well tuned, you are not going to get repeatable quality. If you don't maintain your system will fall out, giving you unreliable quality. If you choose a material from another supplier, you are taking that responsibility and you're the one checking that the material can work with the system. You're the one checking, does it work with the process? Because the process wasn't built for this. They are different. It may be the same name, Inconel 625. There's many Inconel 625s in the market. They all don't work the same. There's many 316Ls. Again, don't all work the same. And again, the process. We're very stringent in our processes. We can give them to you and you can adapt them to whatever you wish. A lot of people like to have their own control. But when we build a process, we want to make sure it works. Why? Repeatable quality. The difference between EOS and its competition, be it SLM, BLT, FARSUN, we can all build one great part. Everyone can build one great part. And in any material, generally, you got a laser, you can build a great part, and we're going to go to Formnext in a few weeks, and you'll see many great parts. But we're not trying to build one great part. We're trying to build 100, 1,000, 10,000, 500,000, 1 million. That's production. If I want to build one part, we go back to prototyping, and any system will do. Yeah, and you can try 3-4 times, you can try different materials and processes, and you'll get there eventually. But if you want to build 1,000, 10,000, 500,000, this is where EOS really stands apart. This is where we take the step left and take the lead. This is why we are leader today. And it wasn't because our machines are faster or we're the cheapest. Everyone here knows we're not the cheapest. Yeah, we're not trying to hide that. We're trying to get better. Our TCO is getting better, I'll show later. But it's about that you can trust us when it comes to production. When you buy 2 of our systems, we want to build 10,000 parts, you will build 10,000 parts. And the scraps will be much lower than our competition. So what do I want to do with you today? I want to build an application with you today in the same ways that my Finnish colleagues do, maybe a little simplified, just to show you how difficult it is. Just a little idea of how really difficult it is. So the application we're going to build together is a dual function inductor. Requirements, reduction of components and overall mass, that's pretty much any AM application. Maximum thermal conductivity, that limits our material selection, definitely for sure. Buildability to enable steady design, again, at general. So we have 2 things. We need a build, general geometry, and we need maximum thermal conductivity. So what does our team in Finland do? Material, not system, material. We take a look at material. And right now, they'll take a look at material with thermal and electrical conductivity, and does the powder chemistry and oxygen content fit our process? Very simple first step. Next step, system time, a bit of fun, a bit of experimentation. We need to have the right energy for the material, and we start doing design variations. And what happens there is, you can see with 5, 4, 3, 2, 1, it generally gets better. And what are we using there to plot our course? Data. Data is our map. We already have 30 odd materials. We already know how different materials work with the laser. So we have a good idea how to really bring this material through. So that's the first fun part for the team. And then how the heat stability is with the system. Next, is it the right recoder? Yeah? Do we need a software coder, a brush recoder? What is the application's real requirement on fine details? Then we take a look over here. Are we able to achieve the right build load on the platform? So let's build more parts on the platform and see what happens to the process then, instead of just building little tensile bars. Do we get a splatter effect within the build chamber? It means maybe we need to lessen the scan speed of the system to bring down the splatter. Each part of the triangle has different effects on the part's reproducibility, on its repeatability. And we have to take care of all this. And this is just, again, a snapshot of what we have to take care of all the time to make sure that this happens. A material provider can only do so much. They don't have generally our systems, and they don't generally have anywhere near our know-how. You need the system know-how and the process know-how with the material to make this really happen. And that's how you build the quality part, in a very simple way. Yeah. So entering production with EOS, we're trying to make it the safest option for our customer. So when a customer comes to us and they have an application, of course TCO is very important. Yeah? The quality criteria is very important. But what people miss is, when they enter production, be it with BLT, SLM or whatever, what's the scrappage rate really looking like when we start building system after system, batch after batch material? Does system A and system B do exactly the same? Do they do exactly the same with different lots of material? How does that change everything? Scrappage rate generally goes up 15, 20, 25%. So how do we control the material? This is a basic quality assurance map of how EOS runs its material. Generally starting over here with the voice of the customer and us asking for material requirements into our material supplier network, getting the batch, testing it. Coming in here, we have a raw material quality control. This is a powder analysis. Then we have AM part production and quality control. This means we build with the material. Why? We want to prove to you that our material data sheet, we can reach it. So everyone has material data sheets that got off different suppliers. Before you get our material in there, we prove it. So every batch of material has a mill-test certificate. You get it. You see the system. You see what we built with. You see our setup. You see what we achieved. You see the powder analysis. And you're able to say, oh, my quality assurance has started with EOS right away. We collect the data. We love to collect data. Why? Because we're always going to be producing new materials, and the data will help us plot new materials and quicken our reaction to market time. Documentation is for you. Mill test certificates. Now this is the key to quality assurance for any industry. If it's medical, aviation, defense, you have that as a starting point. And then I'd like to really push on material supply. This is us being flexible. We can give you flexible lots. Yeah? And we trace the powder as well. So we got powder traceability and also flexible lots that we can give our customers. Some customers like 800 kilograms, some like 2 tons. Generally productions have different lot sizes, and we have variable lots for each of our customers that we can give. Oh, and then not to mention export support and service. This is my team. My team's whole aim is support to all our customer base. You don't need to order 10 tons to have someone on the phone with us. You can order 100 kilograms or a ton. We address all our customers the same. You know? That can't be said about my competition, generally. A little bit more about the powder analysis. So what do we look at? Powder chemistry, skeletal density, water content, morphology, and PSD. This makes sure that what we're getting and asking for in terms of raw material, we're getting. And I can tell you now that we have failure rates. We don't always get what we want, and we have to turn this away. And these failure rates is what we're stopping from coming towards you. We talked about laboratories and testing. NADCAP laboratories are used for powder analysis and part analysis. We do have our own laboratories, but we use NADCAP as accredited laboratories. Our quality assurance. Over 1,000 different lots have been tested since 2005. We have thousands of different data points that we use. And we have about a 3% say failure rate in our supply chain when it comes to the powder analysis. So how do we turn away? I want to skip this one because I'll address it later. So again, AM part production. What exactly we're doing is we have a system, a qualified system, M290 or an M4-4, using a software that we put in our sheets, as well as our own material, giving you the setup of what exactly we've used. It's important that you see what we used and that we haven't used some magical system in the background to achieve these results. No, you should be able to achieve the exact same results with our system, software and process. This is a snapshot of our mill test certificate, and inside you have our powder analysis, PSD, chemical. You have the system setups, the software setups, the versions, our test methodology as well as inside, so you can see exactly how we tested this to get the results. This is sent with every single batch of material. So if you order material with us, it doesn't matter if it's 10 kg, 100 kg or a ton, you get a mill test certificate. Every time. At EOS, we have 7 metal material families across 3 main systems today. You've seen these 3 systems. We're not going to speak too much about the systems. But we have aluminium, copper, supernickel alloys, steel, titanium, cobalt, chrome, and our factory metals. Sorry, blocking the screen as well. So here you see our updated portfolio. This you can get off our website. It is there as a PDF. You see 45 different materials to date. 45. We also have some customized materials that are not on this sheet that we have customized for our customers that is not released. I think we have 25 different customized projects in processes and metal materials to date. But these are 45 different materials today that you can run on your systems with our processes. So exactly what EOS OI does, of course we develop our metal materials, we've got our metal powder manufacturing, we have also a general source of raw materials. Of course you cannot manufacture all these materials yourself. The amount of atomizers you would have would be insane. Development of the metal processes is of course one of the most important parts. This is what brings the system and the material together. This is the gel. This is what brings our repeatability. We also customize materials and processes. We've got our quality management system in place. We do also have medical product competence, as we have clean rooms as well, and our laboratory, and then we have regulatory affairs and compliance. As we address the aviation industry, we keep samples for over 30 years for every batch. So for every batch, there is a sample which we can build with to double check if it was okay. So if there is a root cause analysis and the investigation leads to the material, we have the ability to check it with you. We have the ability to build with it again, to see if it really is the material. And we can do this together. And now here's a short video.
This is it. A perfect result. The prerequisite for additive manufacturing in serial production is quality. In every detail. System, material, and process parameters. At EOS, we have mastered and orchestrated this triangle, shaping the perfect interaction between laser and material. As the technology leader in 3D printing for both metal and polymer parts, our name stands for comprehensive reliability. But how can we guarantee that? All our systems are mature and fully tested before shipping. Every single system produces defined reference objects which we analyze regarding surface properties, tensile strength, and elongation at break. This standardized acceptance procedure ensures a consistent production result for our customers worldwide. How do we achieve the perfect material quality? Our experts review the physical and chemical properties of each batch of raw material. that guarantees and verifies the optimum condition of all EOS materials, specified in internationally recognized certificates that grant reliable quality assurance for our customers. At EOS, we optimize the interaction for components with application-specific characteristics. Our process parameters are based on a good 30 years of experience in additive manufacturing. More than 100 systems at the company headquarters in Germany, in EOS technology centers, and at branches around the globe are operating 24/7 to validate each and every parameter set down to the finest detail, resulting in reliable, intelligently coordinated parameters. Our systems achieve part properties that meet even the highest standards of industrial production in every part.
You can imagine that's my favorite video because it pretty much says my whole presentation in 2 minutes. Yeah? I actually does it better. Yeah. Okay. So before I talked about, keeps jumping ahead. I'm going to win this. I'm not going to win this. I'll leave it. So, not me. Alright, let's leave that, do that. So before I talked about the gap in additive and how we want to make this gap in terms of these grey areas when I mix a material, when I mix a system, and a process, even from EOS. So when we release a new material, the important question is, how mature is it? What have you done to test it? And to do that, we want to bring more transparency to the industry by bringing out TRL levels, so technical readiness levels. That's been developed by NASA. Yeah? But we can take that and make it a very simple way also for what we're doing. So how mature is the material in development? How mature is the process in development? And at the moment we have a mixture between core and premium products in our portfolio. And then we also have our customized products. So our customized products make this a little easier because I don't have too many slides on this. You can come to us with a material and an application, and we can work with you to understand if this material can be used in additive. If this material can be really actually additively built to a level where it's repeatable quality. If it can, we have TR level 3 to 9 with different data points and different tests along the way. And what we do there is with you, we map out how difficult it is to actually do this with the material, how long it will take and how much effort from our side and resource it will take. And we agree on a project that will bring the maturity level from A to Z. Well, we're able to pretty quickly, because of the data, again, the data, we're able to pretty quickly understand if it's possible to go the full distance. Sometimes it isn't. A lot of customers go for the 3. At that point you have characteristics of the material, you have basic geometries of the material, it's also cheaper. But at that point you're able to achieve most of what you need in your application. After that point it's about maturing it and tuning and fine-tuning the process to reduce the scrappage and things like this. So this brings the level up. Oh, I thought to delete that slide. Let's go one again. So TR level 3 is what we generally aim for before we release anything. And when we release this, it's about being fast to market. There we want to work with customers, be it in the nuclear industry, be it in a new medical application, be it in aviation. There, when we feel like we've achieved the basics, the geometries and everything, there we want to work with a customer to fine tune it. So generally we find a top tier customer in the industry, and we work with them on the material and the process to bring it up to the next level. Tier level 4, it's all about refining, readjusting, retuning. This is all about, is the parameter correct? More laser power, recoding speed, scanning speed. What is exactly needed? Once we go from 4 to 5, we lock it down. Yeah, it's all about design freeze. Here we lock down the process, we lock down the material, it's PSD, and everything is locked. We feel confident in the repeatability and the quality. In this, you will get the MDS, you'll get a material data sheet. So at TR level 3, you still get a material data sheet, what we're achieving at that point in that maturity level. You still have a material safety data sheet, and you have a material test report. Not a mill test certificate, a material test report. Why? Because even at TR level 3, we might change the formulation of the material for a better formulation. So it's not design frozen yet. TR level 5, again, material data sheet, we have the safety data sheet, but here we also have the mill test certificate. Why? Because we have frozen the material formulation. And then we have TR levels 6, 7, 8, and 9. And this is more about confidence level. Yeah? Confidence level in our data. We've been collecting data this entire journey for the material and the process. TR level 6 is about what are we aiming for. Yeah? What do we really want to aim for with this material? And there we still have our inspection certificate for each lot, our MDS, and our material safety data sheet. But with there, we have statistical data for many, many years. There we can predict to a very confident level how the material reacts with the process in our system. And our confidence level is super high. And that ends the metal part of the presentation. Now to the polymer. Polymer would be a lot of the same themes, just a little different. As polymer is with additive. Kind of the same, laser material, but it's more of an oven compared to the higher power laser of metal. So trends we see in the polymer space at the moment. Industry. We're seeing more and more industry applications come up, but still not enough. I think that, I'd like to say more than anything, we see more and more of these applications, drones, eyewear, but still not enough in what we thought about 10 years ago, 5 years ago. More materials are being needed. So we still need more materials in the portfolio. Generally, 90% of SLS is PA12. Yeah, I know there's some users here, mostly PA12 or PA12 mixed material. And then sustainability in two different ways. We have one way, a lot of people are asking us for the CO2 footprint of our materials, especially polymer. And the second way is that with polymer you get waste. You have waste, we don't like waste. And this is where we've been attacking next. So the industry. Still the challenge today is that cost, repeatability and reliability are still the general problems of SLS. Still competing against injection molding. Still not cost effective enough, still not reliable enough, still not reaching that same quality level. You know? Even though EOS has a large range of materials, I've done a bad job. Why? Because you don't know about them. We have over 47 polymer materials in the EOS portfolio, but everyone uses 1 or 2 or 3. I've got 47. So we need to do better here. I need to shout this message out a little more. We have more to test with you guys. But we are getting requests when it comes to production and applications for different materials that are used in different industries. We have different solutions that are available today. And then sustainability. Again, we have different solutions here. We have biosourced materials. We have high refresh materials, which means much less waste than you had before. A lot of customers are coming to us asking for LCA reports of our materials, which we've started to do and rolling out as we speak. We do have LCA reports for PA12, we have LCA reports for PA11, and as well as aluminium and some metal products too. So this is starting to roll out one at a time. But like I said before, 90 plus materials, it takes time to do the calculations. So how do I ensure, that's skipping to the answer, how do I ensure, repeatability and reliability in polymer? It's the triangle, except it's circular this time. Yeah. Sorry, I stole that slide off the polymer team. They didn't have a triangle, they had a circular thing. But again, material, process, system, you need to have each side finely tuned, especially in polymer, to get the best repeatable result. And no one, and I mean no one in the SLS side of the world does it better than EOS. No one does it better. In terms of part accuracy today, I have customers running at 100 micron part accuracy today for a jigs and fixture application. On our standard systems, we have a customer in FDR system doing 30 microns part accuracy today in SLS. Never before been seen in the industry. Most people are happy with 500 microns, but it depends on your application, depends on the customer. Is 500 microns a sea, an ocean, or is it very small for your application? But today, we have achieved it. It keeps running ahead. A lot like the metal, we have the same process for our polymer material. We need to control the polymer material as well. That includes, we do a pre-delivery inspection, we do incoming quality inspection, production control, material and specimen quality control, and then not a mill test certificate, but you get an inspection certificate. Again, we're analyzing the material as it comes into, as the raw material comes in. Running ahead again. We don't only analyze one sample, but many samples through the entire production of the material. It says here we do 100 test specimens per batch of material. This is a lot of data that we also collect and also give to you. And again, it's all about this part here. If I can hold this slide for 2 seconds. Come on. Powder and part properties. This is what's really important for everyone. If you can't keep achieving it, it's a waste of time. And again, here we have actually a very similar number. In the last 35 years of us shipping material, how bad am I? 5 minutes? 10? 10, just said 10. We have 3% failure rate going out to you guys in the last 35 years. And we've had problems along that journey in our supply chain. But less than 3% is still a very, if you could see the amount of polymer I've shipped to you all in the last years alone, you'd think 3%, you know? But no, it's actually very low in comparison. And why we do this? It's all about saving you money, saving you time, and having other industries build trust into additive. Yeah, we're still very niche. Yeah, we've barely cracked manufacturing. Now I've got to hurry up a little bit. This goes for metal and polymer. And this should be the question to every time you have a customer in terms of applications. We need to know the mechanical stress, regulatory requirements, thermal stress, electrical stress, etc., to understand what material will fit your application best. It's not always PA12. It's not always 316L. We have a full lot of portfolio materials there that could fit it better. And this is where I want to invite you to come to me and my team and ask. We want to help support you in picking that material. Again, a very short. Again, we have 47 different materials on the polymer side, P11 family, PA12 family, mostly used, versatile, and we have a high reuse version, bio-based. We have a climate neutral version. We have TPU, alamide, 3200, and then we have some FR materials for aviation and electrical and electronics. Processes, we have 54 different polymer processes. We have over 120 metal processes. And the difference here is it takes us 2 years to produce each one. So you can imagine how many people we had working on these post-processes or these process parameters in the last few years to get 54 polymer ones. Check out our website. All our material data sheets are there. You'll get a great overview of our materials and see exactly what you can achieve with our materials right away. We're looking at drinking water certification next. This is what's next for us. Okay, so I talked about what we've seen before was EOS in terms of our portfolio and how we do it. And then we have also ALM. ALM is something that Tina mentioned in her presentation. When it comes to EOS materials, we're looking about creating materials for production. But we also have ALM. ALM does customized solutions for you guys. Maybe you don't Maybe you want to test out a new material variation that you have an idea that could work for an application. You're not fully sure yet. These guys will make it for you and give you a quick parameter to work off. I always call it the quick and dirty way. Yeah? But sometimes that's exactly what we need for that moment. Something that works and that we can build on, like a foundation. So with ALM, we have materials and we have the knowledge in-house to tailor materials for your requirements. It could need more glass, it could need more carbon fiber. And today, we have a large range of materials that we've used for different industries and different customers along the way. And the ones with the asterisks are working on EOS systems with a process today. Again, we'll touch on the sustainability really quickly. We are trying to create transparency in our portfolio, showing exactly how much CO2 footprint is in our products. We have a calculator online, a CO2 calculator, where you can actually put your inputs of your production inside and have an approximate, very narrow, of exactly what CO2 footprint is your product actually coming out of AM. And then we are looking to reduce footprint in our products by offering high reuse polymers, for example, or recycled feedstock metals in our portfolio. So there you'd have a lower CO2 footprint of the products we give you. There's three areas. Umavo is a Munich-based eyewear company totally using AM to produce eyewear. They have a B2C business where they will scan the customer's head and then they will build the eyewear frame exactly for that person. I'm wearing glasses, I hate them. I get headaches. It's one of the problems I have. I need to do this, still very lazy. Haven't done it yet, will do it. But also they have a large focus on sustainability as well. And they use our sustainable products. And with that, they're able to achieve 44 to 58% against standard traditional ways of making eyewear. They're able to save CO2 footprint. This is our PA2200. Here you're seeing a display of its CO2 and the comparison to 3200GF and PA11. Here is the comparison to our new PA2200 carbon reduced and our PA11 climate neutral. So basically the climate neutral one's 100%. Showing you the difference we've made on these two products. If you use the sustainable products with us, you'll get an LCA report on the product itself. You'll get a participation statement. And after the calendar year, once we've had an external audit done, you will get your customer certificate exactly how much CO2 you have saved using these products. Last two slides. Last two slides, I promise. This is important stuff though. We're talking about pricing trends now. So PA12 has come down by over 20% in the last few years. The metals have come down over 30% in the last 3 years. What does that mean? It means all the business cases that didn't make it due to cost, we should re-evaluate it again. The cost per part due to materials is generally 40 to 60%, depending on the system, process, and application of that entire cost per part. If the prices have come down 30+%, we need to re-evaluate them again. Now those business cases could actually pass with the materials pricing we have today. With that, that's the end of the presentation. The only thing I want to do is to invite you all to challenge us. Bring us your application, bring us your challenges. We will support you with Norm on your journey with AM. That's it. Thank you.